Hey Pre-Calc students, I just want to start out today with just like talking to you guys for a second. It's been pretty much 2 weeks of this online learning stuff, and I just want to say I appreciate that you guys have been in contact with me, that you guys are emailing me. You guys have been just so kind and thoughtful, and it just means a lot to me. This is the last video and lesson for the week. I want to give you guys a nice 3-day weekend with Friday off. We're going to just do one problem today, and then you'll have a few problems for homework. We do have one more shape in this unit called the hyperbola, which we'll focus on next week, and then you guys will have a nice spring break. So hopefully we'll be back to school after that, and that would be pretty nice. But of course, if we're not, then I'll be in contact with you guys about what we're doing next. But again, I just want you guys to know that if anything's going on, if you can't get your work done, if it's too much, if you need me to shorten the assignments, if it's too hard, if whatever's going on, just make sure you guys email me, because I don't want you guys to struggle through this alone at home. I know that this is not ideal, and here I am just chatting to you guys, and I have no idea how how it's being received, because you guys can't ask questions, and so I'm just doing my best, and I just really miss you guys. But yeah, so I just wanted to say that I'm actually gonna have to move my phone because I want to zoom in on the problem that we're doing. So hold on for a second. In the meantime, if you haven't printed the problem I wrote about the Petaluma River, you can do that, or if you don't want to print it, that's fine. You can just look at it. Okay, so I'm gonna move my paper for a second, or sorry, move the phone. Sorry, it's gonna be like, ah. Okay, so here we go. All right, so here's the problem. It just starts out with a little bit of introduction. As like I said, as I'm sure you know, I live in Petaluma. If you guys have never been to Petaluma, as soon as this whole coronavirus thing is over, you should come. It's a beautiful little town. So there's this really cute walking bridge, and this side is like Old Town Petaluma that was built in like the 1800s, and this side is like a newer shopping center with like the dollar store and stuff. And this is the Petaluma River. It's a pretty small river. You can like kayak in it, and you could probably have a really small boat on it when the tides are high, but it's a pretty small boat. So this is just a walking bridge, but this right here is a cool ellipse. So what I'm going to do is we're just going to write a problem about how to write the equation of this wooden elliptical part right here, okay? All right, so let me tell you the information I gave you. The bridge is called the Balshaw Bridge, not important, but it says it has a span of 120 feet. So what we're going to do is we're going to go ahead and put that on a coordinate axis. Okay, so everyone should draw like an XY axis. Okay, and if you remember, the ellipse is a good shape because you always put the center at 0, 0. There's like never a question about it, okay? So I'm going to go ahead and go like this, and I'm going to draw on my ellipse, semi-ellipse, okay, where this is the center, 0, 0. Okay, so for the parabola, sometimes you have to pick where you want the vertex, but in the ellipse, you always want the center to be at 0, 0. Okay, so it says that the span has 120 feet. Okay. And then instead of me giving you like this height right here, which I've done sometimes, I'm actually giving you like a completely different point. It says 18 feet from the edge. So here's the edge. Okay, the wooden arch has a height of 7 feet. So right here, this is 7 and this is 18. Okay, so I'm giving you like a point on the ellipse. Okay, so before we actually dive into the problem, let's figure out what point that is, because this is kind of tricky. So this is 120. I'll get my pen out of the way. This is 120, which makes this 60, right? So it's 60 from here to here. Okay, and then this part's 18. So what we want is, we don't want to plug 18 in for x, because that would pull us over here. We want to know how far it is from here to here. So if this is 16 and this is 18, that means that this is 42 from here to here. Okay, so this is the point 42, 7. Okay, so remember, when you put a coordinate on a graph, it always has to be referenced from the origin. So from the origin you go over 42 and up 7, and that's a point on the ellipse. Okay. All right, so we want to write an equation for an ellipse. Okay, we know that the equation, to move this up a little bit. Okay, there we go. Okay, so we know the equation for an ellipse centered at 0, 0 is this. Okay, where this is the x direction, which we know. So we know that in the x direction you go out 60. So this is x squared over 60 squared. Okay, what we don't know is in the y direction, how tall is it? So that's our unknown. Okay, we also don't know the foci because bridges don't really have foci. So what we do know is we know we have a point. 42, 7. So we're going to plug that in for x and that in for y into our equation, and that will help us solve for b. Okay, so in our equation right here, we're going to do 42 squared over 60 squared plus y squared over, sorry, that's not a y, that's a 7. Sorry about that. B squared equals 1. So I put in this for x and this for y. Okay, hold on. Not to be a perfectionist, but I have my cool eraser tape bit, so I'll make that a little clearer. There we go. Okay, so now what you're just solving an equation. The way that I solve this is I subtract this number. Okay, I'm going to put parentheses around it from this number. Okay. When you do it in your calculator, I would type it in exactly the way that I wrote it. So pick up your calculator and write 1 minus, in parentheses, 42 squared over 60 squared. Okay. If you did just that part right, so this is still 7 squared over b squared. Okay, the 1 minus part should equal 0.51. Okay, so if you didn't get 0.51, just try it again in your calculator, type in 1 minus parentheses, 42 squared over 60 squared. Okay, all right, so now we're kind of, I'm going to move up here because I don't want it to write too low. So now we have an equation with a variable on the bottom. What I'm going to do is I'm going to cross multiply to get that variable off of the bottom. So I'm going to multiply by b squared. These cancel, and I get left with 49 equals 0.51 b squared. And then I'm going to divide by 0.51. Okay, 49 divided by 0.51 is 96.078, and that equals b squared. Okay, and if you remember, if it says write an equation, you need to actually put b squared in the equation, okay? So now I know enough to go ahead and write my equation. Sorry, I have to move this again. Okay, so my equation is that x squared over 60 squared plus y squared over the y direction, and that's already squared, equals 1. This is my equation. Okay, and then just because I'm sure you all want to know this, to actually find the height of the bridge, you can't see that, to actually find like the biggest height of the Petaluma Bridge, you would just square root this. So you square root this and you get 9.802. Okay, so then if you go back and look at your picture, sorry, and this is really awkward, right here, that means that this is 9.802, which also means that this height right here, the tallest it gets is 9.802 feet. Okay, I'm going to put that back for you so you can see it again, although you can always pause it. All right, group, so we have covered the parabola and we have covered the ellipse. So now I just want you guys to do a couple problems tonight and then try to absorb it all. Get your homework into me. You can turn your homework in as soon as Thursday, or you can wait till Sunday night. And take care. All right, bye you guys. Miss you.